Here is the experiment in making copper. First, a clean 100 milliliter beaker is weighed on a top loading balance. Next, 2 grams of copper 2 chloride dihydrate is added to the beaker. Next, 20 milliliters of DI water is added to the beaker. And then mixed with the aid of a glass rod. Which leads to the formation of a blue-green solution. Now, .24 grams of aluminum foil is added to our beaker, in which the foil is torn into smaller size pieces. And after the beaker is covered with a watch glass, the contents are thoroughly mixed. And as one will notice, some brown salt is beginning to form, which turns out to be copper, as the aluminum begins to react with the aqueous solution of copper to chloride. Also, some bubbles are observed, and the beaker is warm, indicating that our reaction is highly exothermic. The color of our resulting solution is starting to go from blue-green to eventually colorless. Now, as one can see inside the 100 milliliter beaker, there are still pieces of aluminum foil that did not react with the copper to chloride solution. So to remove the unreacted aluminum foil, small amounts of 3 molar hydrochloric acid solution will be added with the aid of a plastic dropper and continued until all the aluminum foil has been removed from this beaker. After adding some amount of the 3 mole hydrochloric solution, again cover it with a wash glass and mix the contents. As one will notice, bubbles are observed, indicating that there is a reaction between aluminum and hydrochloric acid, in that hydrogen gas is being produced and the aqueous solution is now aluminum chloride. After the addition of the 3 mole hydrochloric acid solution, the beaker is still warm, indicating that it's highly exothermic. Now, to filter out the aqueous solution of aluminum chloride, decant the aqueous solution into another 100 milliliter beaker, which will serve as our waste container, and carefully decant the aqueous solution without pouring out the solid. Rinse the copper solid in the original beaker with small amounts of DI water. Mix with the aid of a glass rod and decant the aqueous solution into the same waste container. Now weigh a clean evaporating dish and transfer the contents in the original beaker containing our copper solid, and carefully move all the solid from the beaker to the weighed evaporating dish. Any remaining copper solid, add small amounts of DI water first to the beaker and transfer it to the same evaporating dish. If possible, decant any amount of water into the waste container, leaving behind as little water as possible. And then heat the evaporating dish over a hot plate, or place it in a 110 degrees Celsius convection oven and heat to dryness. Here is our evaporating dish containing copper and water, and it's on top of a 250 milliliter beaker where DI water is being used as a steam bath to heat our evaporating dish and evaporate any water that may reside in the evaporating dish. Note the 250 milliliter beaker is over a hot plate, which is providing the heat necessary to aid and assist in evaporating any water that is present in the evaporating dish. Once all the water has been removed from the evaporating dish, using crucible tongs, place it on top of a wire gauze or ceramic tile and allow it to cool to room temperature before weighing the evaporating dish and copper. Afterwards, reheat the evaporating dish and copper in 5 to 10 minute intervals. Cool to room temperature by placing it over the same ceramic towel or wire gauze, and we weigh. Continue this process until constant weight has been achieved.